Hello viewers, welcome to my online physics coaching class. Let us make use of the time that we have sitting at home during this lockdown period. I thought we will do some physics classes specially meant for class 12 students. So we start with the first chapter of electrostatics, that is called Coulomb's law. So we begin with Coulomb's law, which is the first chapter of electrostatics. The Coulomb's law is about the force of interaction between 2 point charges. So the statement of Coulomb's law is like that. I'll read it out. The force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. So this talks about the force of interaction between 2 point charges. Let us assume that this Q1 and Q2, these two are 2 point charges and the separation between them is R. That means the distance between the charges Q1 and Q2 is R. Then according to the Coulomb's law, if F is the force of interaction between these two charges, as we know charges can be positive or negative, so if both Q1 and Q2 are positively charged, then the force of interaction between them will be repulsive in nature, and if any one of them is positive and the other one is negative, then the force of interaction between them will be attractive in nature. In either case, Coulomb's law holds true. It says that the force of interaction is directly proportional to the product of the charges. That means we can say that F is directly proportional to Q1 into Q2, and you can also say that the second part of Coulomb's law says inversely proportional to the square of the distance. That means we can write force is inversely proportional to the square of the distance, that is F is inversely proportional to 1 upon R square. This particular form of Coulomb's law, in other words, you also call it inverse square law. Another example of inverse square law will be the law of gravitation, which you have done in class 11. So if we put these two formulas together, we can say that F is proportional to Q1 into Q2 upon R square. So this is how we get by combining these two relationships. If you want to get rid of this proportional sign, what you can do is you have to write F is equal to some constant. So we can say K is the constant multiplied by Q1 into Q2 upon R square. This constant of proportionality has been taken as 1 upon 4 pi epsilon 0. Now what is epsilon 0? Epsilon 0 stands for permittivity of free space. So epsilon 0 stands for permittivity of free space. So if we put this value 1 upon 4 pi epsilon 0, which is a constant quantity, in this relationship, then we get F is equal to 1 upon 4 pi epsilon 0. After that Q1 Q2 upon R square. So this is the relationship, which is the mathematical representation of Coulomb's law, which says that force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges. That means as the value of the product of the charges, which is Q1 and Q2, as its value increases, the force of interaction also increases. And the second part says the force is inversely proportional to the square of the distance between the charges. That means if these two charges are closer, if they come close to each other, then the force of the value of R will decrease. As a result, the force will increase, and vice versa. That means the farther they go lesser will be the force of interaction, and the nearer they come, more will be the force of interaction. Now what is the value of this epsilon 0? It has got a value. It has been found out that value of epsilon 0 is 1 upon 4 pi epsilon 0. If I take it like that, then the value of 1 upon 4 pi epsilon 0 is 9 into 10 to the power 9. Okay, so that is the value of 1 upon 4 pi epsilon 0 SI units. SI units. So this briefly is Coulomb's law, and we will require this formula in order to solve numerical problems based on the Coulomb's law. So we have learned what is Coulomb's law in the previous lesson, and we came to know that Coulomb's law holds true for the force of interaction between 2 point charges, and Coulomb's law is given by the mathematical formula 1 upon 4 pi epsilon 0, after that q1 q2 upon r square. So in this case we have assumed that these 2 point charges q1 and q2, let's say this one is q1 and this one is q2, and the distance between them is r, and in between this q1 and q2, these 2 point charges, there is nothing but free space. When there is free space in between these 2 point charges, then the formula looks like this: 1 upon 4 pi epsilon 0 q1 q2 by r square. But it may so happen that in between these 2 point charges there is a medium. In that case, the concept of dielectric constant comes in. Now what is dielectric constant? It is defined as K, which is dielectric constant. It is defined as permittivity of the medium upon permittivity of free space. That means we can say that K is equal to permittivity of the medium. We can take it as only epsilon, and you know that permittivity of free space is given by epsilon 0. Therefore we can say that epsilon is equal to K into epsilon 0. So like I told you, if you consider that between the charges q1 and q2 there is a medium which has permittivity, then we'll slightly modify this formula. We can say that the force of electrostatic interaction is 1 upon 4 pi epsilon only, after that q1 q2 upon r square. Now that you know that epsilon is equal to K into epsilon 0, therefore we can say that F is equal to 1 upon 4 pi K epsilon 0, after that q1 q2 upon r square. Hello viewers, you have studied so far what is Coulomb's law. We know that the Coulomb's law deals with the force of interaction between 2 point charges. We learned the formula, the mathematical representation of Coulomb's law. You also came to know what is the meaning of permittivity and what is dielectric constant. So let's do one simple sum based on this. The question says the dielectric constant of a material is 3. What is its permittivity? So to solve this problem, we will be using this formula K equal to epsilon upon epsilon 0, where epsilon is the permittivity of the medium and epsilon 0 is the permittivity of free space. Now when you put the value of K, it says value of K is 3. So 3 is equal to epsilon upon epsilon 0. Therefore the permittivity epsilon is equal to 3 multiplied by epsilon 0. Now we need to put the value of epsilon 0. So we will be writing 3 into 8.85 into 10 to the power minus 12. So when you multiply, the result is 26.56 into 10 to the power minus 12, and the unit is Coulomb square per Newton per meter square. So this much today for today's class. Thank you for watching. Please subscribe, like and share. Thank you so much once again.